So I'd like to welcome everyone to this session, Honey, Where Are My Keys? I'm sure all the wives will know that, have heard that at some point. So my name is James Doyle. Anyway, just to introduce myself, I work for VTSU, which is the internal training for the GSS organization. So I was working with the engineering teams during the beta development of this product, VM encryption. So I worked with that for 6 months, just helping them out in developing the training for our GSS organization in advance of the release of SER1392BU. So the idea of this particular module, or this particular session today, is not really to kind of teach you how VM encryption works, especially because I think there's enough documentation on that, and Mike here has a great whiteboard video online if you want to just check that out and just see how VM encryption works. Generally, what I wanted to do today is just to show you that some of the fears that people might have in implementing VM encryption maybe are unfounded in many ways. We've seen lots of questions that come up from people asking about, well, what happens if my vCenter disappears and so on. So what I'm trying to do here is with this session is try to allay a lot of those fears and show you that a lot of the scenarios that you may come up with, that we've thought about those, maybe they might not be so easy through the UI to handle any of these issues, but certainly through PowerCI and some other things we can show you some ways that you can handle and get out of some awkward spots that you might find yourselves in with the VM encryption just through bad design perhaps. And then what we're going to do at the end then is just kind of remind you of some of the things that you should be doing to maybe just make sure that you don't get into those sticky spots in the first place. So with good design we can alleviate a lot of these problems and never run into them in the first place. So I just want to thank you all for turning up. I appreciate it. It was a nice big crowd here this morning and on the last day of VMworld after so many sessions. I appreciate you making the effort to come along to this one, so thank you very much for popping along. Okay, so quick disclaimer, I don't think there's anything really particularly in this module that I shouldn't be telling you about, so I'm not going to spend too long on the disclaimer there, but what we're going to do is we're going to talk about how keys make their way from the KMS, or the key management server, to the ESXi host, so that you can understand how that whole process works and why we might end up in situations where our VM may not be decryptable or may not be manageable for a period of time if the ESXi host can't get its hands on the key that's required to manage the VM. Then we're going to look at what happens when parts of that supply chain break down. So what happens when the key can't make its way to the ESXi host? What can we do to sort that situation out? Is there anything we can do to get the key on there? And then we're going to talk about what prevention is better than cure, and I'll have a little demo in the middle as well about showing what you can do when things go really bad. When it looks like it's unrecoverable, what can we do? Okay, so the first part I just want to talk about is the supply chain here. So how do keys make their way down to the ESXi host? It's important to understand this process to understand some of the problems that you might get yourself into so that you can design your environment to make sure that you don't end up with this situation. But this is kind of the architecture of VM encryption, essentially. So what we have is we have our vCenter and our ESXi cluster, which will be version 6.5, of course, to take advantage of this feature. And then we need to have connectivity to a key management server, or a KMS. So some KMIP 1.1 compliant server that's on our hardware compatibility list. So we have a list for that. At the moment there's only 2 servers, but we're working very hard with the other vendors that we know actually work to get their solutions certified. So if you're looking for a certified KMS, just check that and check it periodically, and you'll see that there should be some more servers there hopefully soon. But once the KMS is connected to the vCenter acts as a middleman essentially, or a broker for getting the keys and passing them and pushing them down onto the ESXi host. So the ESXi host never actually requests the keys. vCenter looks at the registered entities like the ESXi host and any registered encrypted VMs and says, okay, I know you're going to need this host to manage this, or you're going to need this key to manage this virtual machine, so let me retrieve that for you and I'll push it down onto the ESXi host. So he's the main man in the middle there that's required to make sure that keys make their way down to the host in order to make your encrypted virtual machines manageable. So let's say we perform our first cryptographic operation, so anything including registering an encrypted VM, creating a brand new encrypted VM, anything that's going to require the retrieval of a key, it takes place in our ESXi cluster there. So at the moment we have no encrypted VMs, but we kick off our first cryptographic operation. Well, the first thing vCenter must do is he must secure the hosts. So because when an ESXi host has a failure or a PSOD, the entire memory contents are dumped to disk in order to provide some materials that we can use to try and figure out what happened during the crash. But because the keys that we're using here are stored in the ESXi memory. We don't want that information stored in plain text anymore. So we need to secure the ESXi host to make it suitable for managing encrypted virtual machines. So what we do is, what vCenter will do is it will request a key for each of the ESXi hosts in the cluster, a separate key, and they will be pushed down onto the ESXi hosts. So each host gets its own key. And vCenter will remember the key identifier that's required in order to secure that host, so that if the host ever comes back up again and re-registers or reboots, vCenter will know which key it needs to send down to him. So you can see that the first host has a blue key, second host has a red key, and vCenter remembers the identifiers that went with those keys. So you notice that vCenter doesn't actually remember the key itself. He doesn't keep a copy of the key. He just sends it directly down to the ESXi host and only remembers the identifier. So once the ESXi hosts are in possession of what we call the host key, well then that gets installed and core dumps are re-enabled, but this time, every time the host will core dump, the core dumps will be encrypted. We're not going to talk too much about that in this session. What I just want you to know is the requirement for the host key to make the host secure first before it can manage any encrypted VMs. So once the hosts are secure, we can proceed with creating our encrypted virtual machine. So a new key is going to be required to encrypt the virtual machine. That's requested by vCenter from the KMS and sent down to all of the ESXi hosts in the cluster. Okay, so we might be creating the VM on the first host there, but the key that's required to encrypt the VM is sent to all the hosts in the cluster. The reason being is that HA and DRS could be moving the virtual machine around within the cluster, and so we want to make sure that there's no problems there if the VM moves around within the cluster, that all of the hosts have the key that's required to manage that virtual machine. So you can see that the orange key in there is now in possession of both of the ESXi hosts. And vCenter now knows that there's 3 keys floating around or required for entities within the cluster. He remembers 3 identifiers, but you see each ESXi host is only aware of 2 keys. His own host key plus the key that's required to encrypt the virtual machine. So just to remind you just quickly that the keys that we retrieve from the KMS are not the actual keys that perform the encryption of any data. They're only used to secure the keys that the ESXi host has generated to encrypt the data. But I'm not going to go into the technicalities of that. But that makes it much easier then to rekey later, that we don't have to do a complete reread of all data and recrypt of the data if we want to change the keys that are being used to manage the VM here. Okay, so when might an ESXi host actually lose a key that he requires to manage a virtual machine? Well, anytime the host is rebooted, remember that the keys are stored in the ESXi host's memory. So as soon as the host is rebooted, the memory is going to be wiped clean. And so when the host comes back up, he's not going to be in possession of those keys anymore. Okay. So vCenter is going to be required to say, okay, that host rebooted, he's now communicating back with me, I better send him down the keys that he requires, and vCenter will do that. So he'll remember that that ESXi host needs both his host key, which is the red tag there, and he needs the key that's required to manage that virtual machine, which is the orange key. So they'll be sent down automatically to the ESXi host as soon as he reboots. We'll take questions at the end if that's okay, if you don't mind. Is that okay? And I'll probably answer it, I'd say probably somewhere in the session as well. Okay, good. So there's the host key is extremely important, because if the host key cannot be retrieved or cannot be sent to the ESXi host, well then vCenter isn't going to send any of the other keys to the ESXi host either. So even if the key for the virtual machine is available, but the host key isn't, if we can't secure the host, we're not going to send any more keys down to the host. So the VM will be unmanageable even if the key is available to vCenter. So that's just something to watch out for. The other thing that will happen is if you unregister the VM from the vCenter inventory, well then vCenter will instruct all of the ESXi hosts to discard their copy of that particular key. So we don't want to keep any of those keys that are no longer being used to manage anything sitting in the memory on the off chance that somebody might come in and find some way of taking that out of the host memory. So for safety, we just have the ESXi host discard their copy of the key. Okay, and then also vCenter, because he's tracking all of this, if we look into the vCenter database and we see about the registered entities, again, if the VM is unregistered and all the hosts have discarded their copy of the key, well, there's no need for vCenter to remember that key tag anymore. So you won't see a reference to that key anywhere in the vCenter database anymore either. If we remove an ESXi host from the inventory, So rather than just a disconnect or a reboot, we actually remove the host from the inventory, just like a virtual machine run registering the host. Well, again, vCenter is going to forget that he's going to need that key, so his entry in the database will disappear. And in fact, this is the only way that you can disable crypto mode on the ESXi hosts at the moment. If you want to change from being, having encrypted core dumps and you don't want the host requiring a key anymore, maybe you've moved all encrypted VMs out of that cluster. Well, if you want to stop the hosts from encrypting their core dumps from now on, you'll have to actually remove them from the inventory, take them out of the cluster, reboot them, and register them somewhere else outside of the cluster, just to make sure that it discards its key and says that, okay, I'm no longer required to be crypto safe. Okay, so what happens when the supply chain breaks down then? This is the typical question we get, like, what happens if my vCenter goes and, are all my encrypted virtual machines going to be useless to me? Well, let's have a look at that now. So here's the first part here. So let's say we've lost connection to vCenter. For whatever reason, it could be a network error, or it could just be that vCenter has gone AWOL for whatever reason. Well, just remember that the keys that are required to manage the hosts and the virtual machines are stored in the ESXi host memory. And we discussed a moment ago when a host is going to discard those keys. It will only be when the host reboots or if he is being told to discard his copy of the key. So if vCenter is down, there's nobody there to tell him that a virtual machine was unregistered, so he's going to hold on to all the copies of the key unless he gets rebooted. Okay, so 99 times out of 100, you're probably safe enough as long as the hosts stay up. They're always going to have the keys that they need in order to manage their VMs, which is not going to be a big issue. And HA will continue to operate in the background as well, so and DRS, if so. No, DRS won't work, but HA will continue to work. So if you had a host failure, the VM should start up somewhere else in the cluster with somebody that does have the key. Okay. The only thing then is if your vCenter is down, you won't be able to perform any new cryptographic operations. So if you had an encrypted VM stored on disk somewhere and you wanted to register that to an ESXi host, well, if you attempt to do that, even if you attempt to do it directly through the ESXi host, well, there's nobody there to pass the key down to him, so that operation will fail. So your VM will be unmanageable when you register that. Other things like trying to reboot an ESXi host, the reboot itself will work, but then when the host comes back up, because he's discarded his copy of the keys, he's going to want his host key back. And if there's nobody to give him the host key, well, then he doesn't go into crypto safe mode, and none of his encrypted VMs will be manageable either. So registration encrypting VMs, adding a host into the cluster as well, that's also going to fail, because when we add a new host to the cluster, we want that host to become crypto safe as well. So we deem the cluster to be the security boundary. And so any host that's added to that cluster will also need to go into crypto safe mode, so that operation will also fail because he's not going to be able to get a key, and there's nobody there to request a key for him. Okay, so to understand why we can say that even losing your vCenter permanently isn't going to be the end of the world, I just want to explain to you what a key tag, or what that identifier on those keys is composed of, so that we can understand that you actually rebuild your vCenter from scratch and still be able to retrieve all the keys that you require to manage your virtual machines. So the identifiers that come with the keys that are used to encrypt our virtual machines are composed of two parts. So the fully qualified identifier is made up of the first part here, which is the name of the KMS cluster from which the key was derived. Okay, so that KMS cluster name is a name that you will have given the cluster yourself when you added your first KMS server to your vCenter. So you just manually specified the name of the KMS cluster, and that's where that part of the key identifier comes from. So in this case here, you can see it's KMS-cluster. So the percentage 2D is just a representation of a dash. Then the second part here is the big long UUID string of the individual key that was actually retrieved from that KMS cluster. Okay, so this full part, if I want to decrypt this virtual machine again, I need to be able to get the key with that key identifier from the KMS cluster of the same name. Okay, so it's not the end of the world. So here's what you see in the UI if you were looking at that particular KMS cluster. We see just KMS cluster. It's the name that you gave it yourself. So if I have to rebuild my vCenter from scratch, basically all I have to do is go back and create a brand new vCenter, go into this section here, add a new KMS cluster, give it exactly the same name, and point to the same KMS server that I had previously in there. And that makes all of my key identifiers valid again. Okay, does that make sense? So the preferred method, I suppose, if your vCenter really goes bad and you have to, and it's dead forever, the preferred method would be to have a good backup of your vCenter and just restore that. That saves you from having to go through all of this reconfiguration in the first place. So if you do restore vCenter from a valid backup, all of your KMS cluster settings will already be there, and your DB should be more or less consistent. So the only thing that would be different if you manage to register a VM here or there, kind of just through the hosts. But once the hosts reconnect back to vCenter, the DB should make itself consistent again anyway, so it shouldn't be a big issue. So that would be the first thing. So make sure that you've got a good backup and restore your vCenter from backup if you have to. And if you haven't planned very well and you don't have a backup, well, don't worry, you can still rebuild your vCenter from scratch. And as we said, if you just connect to the same KMS server using the same KMS cluster name, well, everything will be just fine. So don't stress there. Okay, now, so that's a failure with the vCenter. What happens if we have a failure with our key management server? Okay, now this one is much more risky. You need to get yourself mobilized as quickly as possible if you have a permanent failure with the key management server. The reason being is that if the key management server doesn't exist, it's not possible to rebuild it. You know, if you have a backup, then yes, but if your key management server is gone forever, there's nowhere else that we can get those keys from. So you have a short period of time, you have a window of opportunity to get yourself out of a situation where there's a requirement for any keys that belong to that dead KMS server. Okay, so I'm going to show you some details about how you can do that in a short while there, but definitely you want to get mobilized and make sure that you don't leave yourself in a situation where an ESXi cluster gets rebooted and then suddenly can't get keys that are required to manage a critical virtual machine of yours. Okay, you don't want to find yourself in that situation. So if you can, restore the KMS from backup as soon as you possibly can. If you can't restore the key management server, then deploy a new one as quickly as you possibly can. Get something up there that can provide you some keys, okay? Or decrypt your virtual machines. Now, we don't recommend decrypting your virtual machines because you encrypted them in the first place because there's critical information on there. So if we can avoid decrypting them at all in the first place, that would be better. So try and get a new KMS server up and running as quickly as possible, and then you can rekey your virtual machines to use new keys provided by a KMS server that is available. Okay, but if you lose the key, we can't rekey afterwards. We have to be able to manage the VM first before we can rekey it. Okay, so you need to have the key that was originally required for the VM available somewhere to be able to manage that. If you can, take backups of your encrypted virtual machines while they're still, so that if things do go belly up, at least you've got some recourse that you can restore the virtual machine in some format. Okay, so make sure you've got that. So remember that your backups. We do fully supporting backing up encrypted virtual machines, but the backup data itself is in its decrypted format. Okay, so typically what we would suggest is that if you're using a backup proxy, like you're using a product that leverages our APIs, typically you'd have a virtual machine that's acting as a proxy to perform the backups. So what you can do is you can encrypt your backup machine as well. And when you encrypt your backup machine, it means we can leverage hot add. So we can take an encrypted disk from your encrypted virtual machine and we can hot add it to your encrypted proxy server, and it can perform the data copy internally inside in the virtual machine. So that way the encrypted data never goes out onto the wire. Okay? If you don't encrypt your backup proxy, we have to leverage NFC protocol from the ESXi host. So the ESXi host basically acts as kind of like a proxy for the data. So he'll read it, bring it through the I/O filter again, decrypt it, and send it in its decrypted form to your backup server. So that's probably not ideal. So if you're going with your best practices, well, that means that your backup server is also an encrypted VM that probably has a key belonging to your dead KMS server. So it's time to move fast, right? Okay, you do need to move quickly. The danger being is that if you permanently lose a copy of your key and you can't get it back, your encrypted virtual machine will then be unmanageable. And there's no secret backdoor that VMware have designed into this product that you can call VMware and say, it's gone really bad, can you please help me get in the backdoor? I know you've got some sort of code that you can run on this. No such thing. It's really not. When we make it secure, we've made it secure. So we can't even get in if you break it. Okay. So with that in mind, let me take you and just show you exactly what happens here, I've just got a little environment set up here. Okay. Is everyone able to see that okay? The text is big enough for everyone to read? Okay, good. So let me explain the scenario that we're in right here at the moment. So you can see I've got a VM that's highlighted. It's showing up as invalid in the UI. It's sitting on the host SER1392BU vclass.local, which rebooted just not long ago. So what I did is I rebooted it while the KMS server that was providing the keys was actually in a powered off state. Okay? So this is just recreating the issue here where the KMS is dead. This isn't a permanent failure at this particular time. It was just a case that the KMS server wasn't powered on. But you can still see that I've ended up with a virtual machine that's showing as invalid. Now, if I show you what happens in the logs here, I'll show you on the vCenter first. So if I show you this line that's highlighted here, in vCenter, if you want to check for any messages that are relating to the VM encryption, what you should do is look in the vpxd.log, which is in varlog VMware vpxd, and look for the term crypto manager. Okay, so all lines that are relating to VM encryption have the term crypto manager in them, like you see here. Okay. So what you can see here is that vCenter knew that the ESXi host that rebooted, I think ESXi01, was requiring a key, and so it attempted to retrieve that key from the KMS server. But what you get here, the error message that you get here is that it says QLC error communicate. So it tried to talk to the KMS server, but the KMS server never talked back. And so it reported that, whatever reason, I went to ask for the key, nobody was listening. That's what you're seeing in the error message there. Okay. And if we take a look at the host logs here, the ESXi01, what you'll end up with then is that when your virtual machine attempts to power on, we attempt to read the VMX file to load it up and get it working. We realize that the VMX requires a key in order to unlock it. And because we can't retrieve the key, we get this state here, which is VM state locked. So if you see that, you know it's a problem with retrieving the key that's required to manage this virtual machine. We can't actually open the virtual machine. We can't open the VMX file. We can't open the disks. We can't do anything because we can't get a copy of the key that's required to do that job. Okay, so I'm going to make the scenario a little bit more serious. So what I'm going to do is I'm going to go to my KMS server, which was previously powered off here. And I'm actually going to do a complete KMIP reset, which is going to basically tell the KMS server, I don't need any of those keys anymore. Just wipe the whole thing, and we're just going to start from scratch. So you'll see that the error message will be slightly different when I do that. So, oops, I forgot to power it on. So we'll just give that a second just to power on, and we'll just show you what the error message, how that will be different. But in the meantime, let me just go back into, we'll go to Power CLI first. Well, that should only take about a minute to power up. So the UI is great. I mean, VM encryption is very, very simple to implement. It's just a case of applying a storage policy through the web client, assigning that policy to the VM and to the disks, and then you've got your encrypted VM. It couldn't be any easier once you've got your KMS set up to apply VM encryption. But there are a few little gaps in the UI, in my opinion. We can't do the rekey operation directly through the UI, which would be ideal, so I think we'll try and work on that, on getting that somewhere in the UI in the future. But there are APIs that allow us to do all of this. So we have developed a Power CLI module that you can download separately. So it doesn't come if you install Power CLI on your system, or you go to the PowerShell gallery and you download the Power CLI modules. It doesn't come by default with the VM encryption module. So we'll at the end of the slide demo, we'll show you where you can get this module from. You just need to download it separately and just load it up. But what I'm going to do is I'm just going to show you some of the Power CLI commands that are available. So So here are some of the commandlets that come with the PowerCLI encryption module. So you can see we've got things like we can do some queries to figure out information about our KMS cluster. Now, a lot of these things are also available through the UI, but if you want to do some automation or you want to run some reports, these commands are going to be useful. But for the purposes of this demo, the commands that I think are the most useful here are the ones that we see down at the bottom here, which are set VM disk encryption key, set VM encryption key, and set VM host crypto key. They're the commands that will allow you to request a brand new key for the entity that you're going to specify in that command. So if I say, for example, set VM encryption key, there's a few little things that you need to do, but if I chose my test VM as the key, the VM that I wanted to change the key, what it's going to do is it's going to go back to the default KMS cluster that's currently connected to your vCenter. vCenter is going to request a brand new key for this guy, and he's going to replace the current key that's being used on this VM with a new key that's just been requested from the default KMS cluster. Okay. So let me go back to our key management server here, and let's perform the reset. I just want to show you how the behavior is different and what error messages you're going to check for, which ones you should be panicking about and which ones you shouldn't. It's fat fingering. Okay. So this is just a trial version of the high trust. It's just an easy one to use. Okay. So I'm going to do a reset here. So what this means is that the KMS server will technically still be available to vCenter, but he's not going to have any of the keys that vCenter is going to be asking. Okay. See the big warning there? Okay. Here we go. Ready? Fingers crossed. Let's go. Okay. So the KMS server now has been completely reset. You can see that it's actually been disabled. So what I'll do is I'll just re-enable it just for laugh. Just that there's actually a KMS server there and a KMS server that's listening. Now, if we go back to our UI here. I didn't hit save yet. You're right. Thank you. That annoys me, that does. Okay. Let's go. So if we go back to our web client and we just have a look at our vCenter here. If we look at our key management servers, we can see our KMS cluster, which is the default here at the moment. It'll just take a moment or two now, but that should re-establish trust connection because the certificate that I have installed there should still be valid. That won't take long there to come back into a connected state. So it might seem that, there we go. So it might seem now that vCenter, when we look at the fully qualified identifier for the virtual machine, it says KMS-cluster, and it's going to look for a key identifier for unlocking my virtual machine. It might look like everything is okay now because I can see my KMS cluster. But let's just do a quick reset. So if we want to, what happens at the moment is that if the host reboots and vCenter is down at the time that the keys are requested, once the host comes back up, if we reestablish connectivity with the KMS cluster, vCenter kind of gives up after a short while looking for the keys. Okay. So if we want to make vCenter go back and say, go and get those keys for me again, you don't have to do anything too drastic. You can just do a disconnect and a reconnect. Okay. So if we disconnect and reconnect, that kind of forces vCenter to have a look at everything that's on that host again and decide if it sees any keys that are required, it's going to go back out and re-request them again now. Okay. So what we should see now is that the error message that we see in VPXD log will be slightly different. Okay. Whereas before what we had was this QLC error communicate message. Okay. Let's show you what we're going to get now. Uh-oh. Okay, so this time now the error message is different, okay? So he's gone out looking for the key with the identifier ADE4499, etc., etc. But this time, unfortunately, it says the key is not found. So it hasn't told us I couldn't talk to the KMS server. It says I went and asked the KMS server for that key, and the KMS server came back and said, I don't have that key. So that's slightly more problematic, okay? Because that means that key is never coming back from that KMS server, okay? Unless you can find some way of restoring the key from some archive or other if your KMS server allows you to do that. So that error message now means that we're in a very precarious situation, okay? Because our virtual machine here is now sitting on this ESXi host 01, but the test VM is still showing up as invalid or locked. Now, if I right-click on that VM, look at what I can do with it. Not a lot. So I can't right-click in it. I can't say migrate. I can do nothing with that virtual machine right now. Okay. Does that mean that all hope is lost? Well, not quite. Not quite. Let's take a look. Let's go back to our Power CLI here. So what we need to do here in this situation, if we find ourselves in this situation and we know that there's only maybe one host that's been rebooted, we know there's other hosts in the cluster that may potentially still have the key that we require, but we need to go and we need to verify if there's any of those hosts that actually have those keys. I'm going to show you what we can do. So the first thing I want to do is I want to find out the actual key that's required in order to unlock my VM. At the moment, I'm not too concerned about my host because it's actually very easy to rekey a host. I can just request a brand new key for him and that won't be a problem. The worst thing that could happen there is that any core dumps that were previously generated, I don't have the key to decrypt those. That's the worst that can happen with losing your host key, really. Okay? But if I lose my virtual machine key, well, there's real critical data on there. So I need to be a little bit more careful. So what I'm going to do is I've created a variable here already. I'm just going to load up some pre-generated scripts here. I'll show you how these scripts are working. I'm not going to leave you in the dark on that, but just I've created a little host variable. It just has test VM here is get VM by the name test VM1, which is our locked virtual machine right now. Okay. So what I'm going to do here is I'm just going to call that command test VM1, and I'm just going to pipe it into get VM encryption info. Okay. So what you get when you run that command is not a lot of information, really. It does tell us that the virtual machine is encrypted using the VM encryption policy here. And it does tell us that it has a key ID, but it has this kind of unfriendly, just kind of, what would you call it? A property value there of crypto key ID. It doesn't tell us what the actual ID is. Okay. So what I'll do is I'm just going to create a variable out of that command here. Okay, so I'm just going to go test VM1 info equals. So I'm just going to create another quick variable on that. This is how we can pull out the different properties of the VM. So I can just go test VM info and then just go dot and have a look at the property called key ID. And now you can see the key, the actual key identifier that's required in order to unlock my VM. Okay, so it begins the AD9EB, that's the kind of the key that we need to look out for. And if I want to know who provided that key, if I want to know the name of the provider, I just go provider ID here as well. And it tells us that that key came from the KMS cluster. Okay, so we're just pulling properties out of the virtual machine here for the registered virtual machine to kind of figure out, well, what key is actually required to unlock that VM. So what I've done is we can do similar things with the hosts as well. Okay, so we can dig into the hosts and we can have a look in some properties on the ESXi host if anyone is interested in how I built this. These scripts I've actually made available on GitHub if you ever want to download them. I'll send you some details about that if you're interested in doing that. But I'm just going to run this command here. What it's going to do is it's going to run through all of the hosts. It's going to look at Virtual Center and ask Virtual Center what key tags do you remember. He's going to go through every host and it's going to find out what host keys the host is in possession of. And then it's going to go and find any encrypted virtual machine and just put a little report in there to say, well, what key is required to unlock the VM. Okay? So that's what the script is designed to do. So let's just run through that quickly here. Okay. Cool. There we are. So if we run back up here, well, let's look at our test VM1 first. Okay, so test VM1, if we go to the bottom here, you can see our key that's required is AD9E. Okay, that's the one that I want to look for. So we're kind of safe in the sense that vCenter knows that key is required in the environment. Okay, so we know that vCenter, when he gets the chance, he will actually go and look for that key. Okay, so I think you can see it just. Where is it? There it is. There, look. Okay. So vCenter still knows that the key is required somewhere. So at least we know that vCenter will go and ask for that key. when he needs to. So the next thing we need to find out is there any host that still has that key? So you notice there SA ESXi01, he has no keys at all in his cache because when he came up, the KMS wasn't available, and then I reset it and the KMS didn't have the keys. So now when he was rebooted, he's lost all the keys in his cache. Okay. But if I scroll down and have a look at the other hosts in my cluster, the key that I'm looking for, AD9E, is still sitting on ESXi02. Okay. Not too bad, not too bad. We still have a chance. We still have a chance. Okay, so what would you do? Unregister it and re-register it? So what happens when you unregister your virtual machine? Okay, if you unregister the virtual machine from your vCenter inventory, what's vCenter going to tell all the other hosts to do? Discard their copy of the key. Right, God. So I can't migrate it, I can't unregister it. What the heck can I do? Okay, so if you're following our best practices, we'll have told you that you should have your ESXi host in lockdown mode. Well, now's the time to disable that. Okay. So what you're going to need to do is you're going to need to go to a host directly. So in this case here, what I'm going to do is I'm going to go to ESXi02. I'm just going to log in here. Okay. I'm going to browse for the VMX file. Oops, if I just go back here. Still getting used to this. Let's register a VM here. Test VM1. There he is. There's my VMX file. So I've gone directly onto the ESXi host here. So I haven't unregistered from vCenter. So as far as vCenter is concerned, he doesn't know what's happening down here. Okay, we're bypassing vCenter. We're tricking him a little bit here. Okay, we're going onto the ESXi host, and we're going onto ESXi02, and I hit register. Now, from vCenter's perspective, there we go. We've already solved our problem. Look at that. So from vCenter's perspective, the VM was never unregistered. It just swapped hosts. Okay. So vCenter never saw that host, it was never a time when he wasn't managing that host, that VM, should I say. All he noticed is that the VMX swapped to a different host, which he's quite happy with. Okay? So in the back end, what I've done now is that guy is now running on SA ESXi2, which is a host that does still have the key. So we've just rescued our VM. Okay? Now, what would you do next? So you know that the not found message was found in your vpxd.log there, so you know that the key is never going to be retrievable again. What happened if I had an outage that caused a reboot of all the hosts in my cluster? That VM would be dead forever. Okay, so you've got a chance here, we've rescued the VM, but it's only temporary. We've got whatever the paddles are. We've just zapped his heart back into life again there, but he's probably in need of a heart transplant, really. So we need to get him back into a state where he's not using that key that we can't find anymore. So using those commands that we had in PowerCLI, again, let's just run back and just remind ourselves of some of those. That's it. Okay, so some of the commands here. So the command that we want to be using here is the set VM encryption key. But at the moment, the KMS cluster that I've chosen, let's just say that was dead forever, okay? I kind of replicated a dead KMS by resetting the KMS cluster. Let's imagine that guy is dead, okay, forever. And we go on, you do what I told you to do, which is to go and deploy a brand new KMS cluster as quickly as you can. So that's kind of what I've done here. I have a key management server here. I've created a new KMS cluster. So what I want to do is I want this cluster to be the one that vCenter goes to by default for new keys. Okay, and that way then you'll be able to see that the keys have actually changed. So I'm going to just hit that button there, and I'm going to make him the new default cluster. So that means now, unless told otherwise, when vCenter needs to ask for a new key, that's the KMS cluster he's going to go to. Okay. So if we go back to our PowerCLI again here now, I have another script here, which is just to go and find and replace key management server keys. This is quite a long script. They're just leveraging the same PowerCLI commands that you're seeing here. Okay. The idea here is that it just goes through and it just asks you a couple of questions like, is the KMS cluster whose keys you're trying to replace, is it still connected? If not, can you just specify the name? And then it goes looking for any keys that KMS cluster name appears in the FQID, and then asks you then to choose which entities you want to recrypt. So let's just do that. Okay, so it's going to connect. I just need to SA-VCSA01. Okay, I'm sure there's much more elegant ways of doing this. I'm not a brilliant scripter, to be honest, but I just do what I need to do to achieve what I want. Okay, so I've connected to my VC now. Hopefully, yes. So the next question you'll ask me, is the KMS cluster whose keys I'm trying to change, is it still connected to the vCenter? Well, technically it is, because I still have a KMS cluster by the name KMS cluster. But let me just say no for the time being. And then what I have to do is I have to put in the name of the KMS cluster whose keys are to be replaced. So I remember that it was called KMS-cluster. So I'll just verify that. Okay. So what it does then is it goes digging through the inventory to find out which hosts are still using keys that belong to that KMS cluster. So at the moment you can see that, remember, ESXi1 isn't because he rebooted and couldn't get a key anyway. So he's no longer keyed with that. So I can just, I can select these two guys here, hit OK. And I'll just go and rekey those. Okay. And then it goes searching for virtual machines, and it's found 3 VMs that are encrypted using keys from the KMS cluster. So I can just shift and select all of those guys. Hit OK. And do I want to proceed? Yes, I do. Okay. And I also want to encrypt the disks. Yeah, rekey the disks. Okay, there we go, done. So if we go back and run this master key summary script here. So previously we saw that all the entities were encrypted using KMS cluster. As you see as we go through here now, okay, what went wrong there now? We still have test VM 1 and 2. Did I hit no when I hit that? Maybe let me redo that. I wasn't really paying attention. Do you wish to rekey? Yes, I do. Yes, I do. I don't know what's going on there now. At the first part of the screen I have which? Oh yeah, so the host crypto key failed on one of the things. Okay. I'll have to go and check into that and dig into that. But basically the PowerShell script will, or the commands themselves will allow you, if you wanted to do it one by one. I obviously have to just check something that worked every other time except when I come up here, of course. It's typical. But the idea is that once you find yourself in that situation, you should be taking some very, very quick action to get yourself out of that scenario where you could end up in a case where you've got a key that you can never get back. Okay, so it's very important that you think about that. So let me just go back to the presentation here. So, okay, so that's our PowerCLI demo done. Okay, so with all that in mind, ideally you don't want to have to do this at all ever. All right, you can see it's a little bit complex. And you really don't want to find yourself in this situation in the first place. So what can you do to kind of make sure that you don't end up in this situation? Well, the first thing is that you try to make everything as available as possible, okay, including your KMS cluster and your vCenter. Okay, so we've discussed how important your KMS server is. So why would you have only one of them? Why would you put yourself in that scenario where one failure could render your entire encrypted environment unmanageable? You just wouldn't want that situation. So we would heartily recommend that you deploy a KMS cluster. Okay, so a KMS cluster is where you have multiple KMS servers from the same vendor, and they're replicating their keys to one another. Okay, so you should be able to go to any one of those 3 KMS servers, request exactly the same key, and all of them should be able to provide it for you. Okay, regardless of which one I ask. Now, what we would suggest as well is that if you are going to deploy a KMS cluster, if you can, have each of the servers in different infrastructures. Okay, in the case that you had a data center failure, okay, you don't want all of your 3 KMS servers going down. Or if you had major storage corruption and they were all sitting on the same storage, you've lost, what's the point in having 3 of them if they're all going to die at the same time, right? So if possible, try and keep them out on separate infrastructures. If you have multiple vCenters even, or multiple data centers, just split them out into different locations so that you're kind of like you're spreading the risk as much as you can. So with vCenter 6.5 as well, if you're using the appliance, we have the ability to leverage vCenter HA. So that's where we have a kind of an active, passive vCenter setup, so that if the active node goes down, the passive node immediately takes over, or within about 1.5 minutes or 2 minutes or so, you get your other vCenter back up and running. So that kind of minimizes your risk with vCenter, but certainly the KMS, please, 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 please deploy a cluster of your KMS servers, please. Now, with any of these solutions, like having a KMS cluster or having vCenter HA, they are no replacement for having good backups. I don't know how many times this has probably been mentioned in some of your sessions this week. Always, always, always have good backups, please, please. Because even vCenter HA, if you end up with database corruption, with vCenter HA, the databases are being replicated, so you just end up with 2 useless vCenters, okay? If your KMS cluster gets corrupted, you end up with 3 useless KMS servers. So have good backups of everything, because you still need some recourse in case you have a major failure, so that you can get back some of these critical components. The same thing with your virtual machines. Even if you've deployed all this and you have all the resiliency in the world you can imagine, it's still no replacement for having a good backup. Okay? So just keep that in mind, please. Just always have your backups. If your backup virtual machine is encrypted, just make sure that you manage those keys safely as well. Okay, just watch out for that. Okay, what should you be backing up then? You should be backing up your vCenter. You should be backing up your KMS. You should be backing up your encrypted VMs, and you should even be backing up your keys if your KM server allows you to do that. Okay, so if in that case, then if you deleted a key that you thought you didn't need and then suddenly you realize that you did, if you have some way of restoring those keys, that would be fantastic. Okay. And then just some kind of like general housekeeping tips. Before you do anything with encrypted VMs, if you're ever going to unregister an encrypted VM, let's say you're unregistering it temporarily and you're planning on re-registering it somewhere else, please don't do that unless you know that the KMS is available and the keys are going to be available. Have a key lifecycle policy in place. So typically we'd suggest maybe re-keying your VMs every 6 months or something like that, just to maintain your security. So leveraging some script like the one I've got there, if it was working, just running that every 6 months or something so that you're never left running on the same keys all the time. And make sure you're using the permissions properly as well to grant those permissions only to people that actually need it. Don't reboot any hosts unless you know that when it comes back up, it's going to be able to get all the keys at once. Okay? So don't get yourself in that situation where you end up with that invalid VM and you have to kind of jump through hoops to get your VM manageable again. So, and make sure that you don't unregister encrypted VMs either, unless you're sure that they can be retrieved. So the kind of questions that you need to ask yourself, like we went through the demo, is can the key be restored to the KMS server? Maybe the KMS is missing, or maybe it's just that one key that I was looking for that's been removed for some reason. Can I get that back? Does the key exist somewhere else in another host in the cluster? And you can see what we can do if you can find that that's the case. And call GSS if you need help. If you're not comfortable with any of these processes, then please ask for help. Don't kind of plow on, kind of, I think I know what I'm doing here, because it may be too late by the time you call GSS then. Okay, so if you're nervous about it, then just call GSS. We've got the skills and the tools to do this. But if we don't have a key anywhere, if you don't have the key, then I'm sorry, calling GSS is a waste of time. All we're going to do is kind of dig through the environment and say, you know what? That key doesn't exist anywhere. I hope you've got a backup. That's all we're going to be able to say to you. So make sure that you've got both. There is no secret door into the back. Okay, so the key takeaways then, just don't be scared of VM encryption. It's very simple to implement. Very simple to apply using policies, hundreds of VMs. You know, if you're trying to do that with BitLocker for hundreds of VMs, the management tasks alone would keep you busy for the entire week. But just making good design decisions, make sure that you keep your keys available, okay? It's very important. Never neglect a good backup policy, so always have some way to get your VMs back in the case of a big disaster. And as we've seen, that some failures that you might think would spell disaster don't actually necessarily do. So even losing your vCenter permanently isn't the disaster you think it might be. The only time you're really going to get yourself in trouble is if you're careless and if you just don't design properly. That's when you get in trouble. But otherwise, if you are careful, then there's absolutely nothing to fear, and you can leverage virtual machine encryption without any difficulty at all. So now it's time to take questions. So was your question answered?
Yeah, it was kind of answered. So when you rebooted the ESX host, and you said that the host will retrieve the keys from the vCenter, and I was like, okay, the vCenter doesn't have the keys. So how will this happen? So obviously my question was answered that it will take them from the KMS.
Yeah.
And so thinking about it, I would have thought that we are not storing the keys on the vCenter for security reasons, so that it doesn't possess something that might not need or can be hacked somehow. But in the case that at any time the vCenter can actually retrieve those keys, doesn't it make more sense to store the keys on the vCenter as well, so that this is yet another place where they can be preserved in case of failures?
Okay, so the question is like, you know, given that, you know, we could have failures, would we not want a second location for the keys, like the vCenter?
Yeah, when it can be retrieved at any time, so it's not a security problem to store them.
We don't do that because it increases the attack surface, places where you can get keys from. So the whole idea of this process is that vCenter itself would be kind of difficult to secure from that perspective. We then have to encrypt or provide really tight security on the vCenter, which may make your day-to-day management tasks difficult then. So anybody who's got access, which you need to be able to manage your environment, you're going to be giving that ability to lots of your admins because they're going to want to manage vCenter. If those keys are on there, it's going to make it easier then to try and find somewhere to be able to retrieve those keys. And somebody could take that key off site and then take a copy of your VMDK and decrypt it. So the idea with it is really that only the ones that actually need the keys actually get it, which is the ESXi hosts. And you notice that they're not even persistently stored either. Okay. So we don't have any persistent storage except on the key management server, which is the KMS vendor's responsibility to make sure that appliance is secure. That makes sense? So just if we don't answer all your questions here, by the way, myself and Mike Foley will be outside, so if we could be able to take any of your questions afterwards if we don't get to address everything right here. So go ahead with your question.
Is the VM encryption compatible with vSphere replication or site recovery manager? And if so, are there any limitations at all around that?
Yes, there are some limitations right now. It's not, vSphere replication is not currently compatible with VM encryption. Site recovery manager was supposed to be, but it's not quite. So if you were doing array-based replication and you had your other vCenter connected to the very same KMS server with the same KMS cluster name, technically the key identifier should work on the other site as well. What happens though is that during a site recovery manager failover, what happens is that we replace the placeholder VM with the real VM, and we do a kind of a reconfigure of the VM as we're loading it. And unfortunately, we can't do a reconfigure until the VM is already registered. And we can't register until we have the key. So there's a little bit of a kind of a chicken and egg situation there when we do a failover with Site Recovery Manager currently, but we're working on fixing that. Okay, cool.
Just not a question, a quick comment. I know you were trying to have a cataclysmic example here, but at least in the case, at least in the case of high trust, it automatically generates an encrypted backup image of the keys, and then you can always recover it. So, but you have to recover it with an N of M kind of recovery model. So that would be your first choice if you really ran into that circumstance. Yeah. I mean, I tried to cover that. I said if there was a way to restore keys to your KMS server, well, go through whatever hoops you need to be able to get those keys available again. But coming from GSS and seeing all the worst case scenarios, we always see the kind of when the poo hits the fan, we kind of see that sort of stuff. So it was I made it my job to try and think about the worst case scenario. Okay, go ahead.
So when you migrate a host to a new vCenter, if you name the cluster, the encryption cluster name the same, is that how you migrate a host? With encrypted VMs on it?
So you want to migrate a host that has registered encrypted VMs from one vCenter to another vCenter.
Yeah, or how would you do a host migration if you're using encryption?
Yeah, if you want to register to a completely different one, you're going to need to be the identifiers that are used that are stored with the VMX files. So the first thing that's going to need to happen is that any new host that those VMs appear on will need to be made crypto safe as well. So there needs to be some KMS server available to make those guys safe. But
if you're moving a host off of the vCenter, you know exactly where the VMs on that host.
Okay.
Right? And then reboot the host to get it out of crypto safe mode.
outside of the cluster, though. Yep.
And then the new vCenter will put it back in.
So if you're collapsing vCenters, how would you do that? You'd have to unencrypt the VMs, I guess.
You'd have to unregister all of the VMs. They could remain encrypted. But then when you want to recrypt them or you want to re-register them to the new vCenter, whether it's on the same host or a different host, you can just find the VMX file and try and register them. But the VMX file contains the reference to the key identifier that would be required to unlock that VM. So if the KMS cluster, a KMS cluster of the same name exists, and it contains servers that have those keys, well then we'll be able to retrieve those keys and unlock the VMs again.
The VMs themselves are portable so long as where you're sending them to, the VCSA has the same relationship with the KMS server.
Okay.
And it's calling it the same name.
So even in two vCenters that aren't connected, you can
Yeah.
can move VMs back and forth.
You could.
That are on a host.
Yeah. So at the moment we don't actually technically support cross vCenter vMotion with VM encryption. I don't really know the reason why, but I can't see any technical reason why not. Yeah. There's no technical reason why not. In my opinion, I haven't seen any reason why it shouldn't work. All right.
You're close to that. When you got close to answering my question, say you lost your virtual center.
Yep.
You have hosts that are still running.
Yep.
You just reattach those to a different virtual center at that point without shutting them down.
Yes.
Those are attached to that virtual center is attached to the same KMS server with the same name, potentially in linked mode. Not an issue?
Not an issue.
Okay.
Yeah, as long as the hosts haven't rebooted and lost their copies of the key. But even if they have, if you're connecting back to the very same KMS server, well, that just shouldn't be an issue. Can you just get the microphone for this gentleman here?
So actually, you kind of answered one of my questions about SRM. I do have a follow-up question on the, you mentioned good backups, always help, right? But what if you're in a scenario where you're backing up and you're also doing a key rotation, your backup will always be old, right?
So your backup is unencrypted, remember?
I'm sorry?
Your backups will be unencrypted. So even if you're doing a key rotation, the key hasn't been stored with the backed up copy of the virtual machine.
The backup software sees the files in the clear.
Right.
Right? It's the analog I've been telling folks from a hardware standpoint. If I had a Windows server that had an HPA on it, that the HPA can do encryption, and the Windows server has no idea that every write that's going through the HPA is being encrypted. It just sees everything in the clear. When the backup mounts the encrypted disk and has the right permissions, it can see into the VMK if it's pulling out the files. Then it's up to the backup program to encrypt the backups.
But it'll be a completely different key. It won't be the one.
My question is, let's say that if you're in that scenario where you're backing up your KMS and you're backing up your vCenters, and then you're rotating keys, right? Like every 30 days or 90 days, and you rotate the keys and your KMS got corrupted, right?
Okay.
How would you restore that, right? Because now you have new keys already sent to your vCenter and VM, but your backup still has the old keys. Can you?
Well, if you're backing up your KMS and it only has the old keys, well, then you'll be in trouble. But if it's your vCenter, you won't have to worry because as soon as it registers the new hosts, the hosts tell them which keys are required, basically because they're contained in the properties of the ESXi host and the properties of all the VMs. So vCenter goes down and has a look at the properties of the host and all the VMs and kind of goes, oh, he needs that key, he needs that key, he needs that key. I better go and ask for those. And he goes to the KMS server and gets them. So it's not permanently stored in the database. The database would actually be updated. If it was an old copy of the database, when you reconnected the hosts, vCenter will realize, oh, what I thought about that host isn't true. I better update my database with what the host is now telling me, basically. And yeah.
So there is a small possibility that in this particular scenario, even you're backing it up, there's a possibility of that window where you have, let's say an hour from the backup, your KMS got corrupted, you won't be able to restore your environment.
That's why you really desperately need to have a
saying is that the corruption occurs where it will occur in all
Yeah. So just remember, as long as your hosts stay up, they still have their keys. So you could always get another KMS server and rekey.
Okay, so as long as like the hosts are up and your VMs are up, you could just bring up another KMS online.
Exactly. The only time you'll get in trouble is if everybody loses their copy of the key, which would be where all the hosts also rebooted. But as long as your hosts stay up, you're golden. Okay, we're going to have to finish up there, guys, because I'm getting slightly over time.